Hello, good evening students. In today class we have discussed different type of rotors. It is already well known induction motor has two main parts. One is stator, another one is rotor. Stator is a stationary part of motor. Similarly, rotor is a rotating part of motor. These two are very much similar to transformer construction. The primary winding and secondary winding. The stator is referred as primary winding. The rotor is similar to secondary winding. Now you can observe figure number 1 and figure number 2. It is the cross sectional view of a squirrel cage type of rotor. Once again, rotor is a rotating part of electrical machine, that is induction motor. Now you can observe 95% of industrial applications are met by the squirrel cage type of rotor because it has many advantages. It has simple construction, more mechanical rugged construction, high efficiency, high power factor. Its starting arrangement is simple. It develops a moderate torque. All things are favorable. That's why 95% of industrial applications are met by squirrel cage type of rotor. It is already observed the rotor is a cylindrical drum. The rotor slots are punched on outer periphery of rotor core. The rotor slots houses the rotor windings. The induced current in the rotor winding is very high. Therefore, instead of circular conductor, we are using bars, copper bars or aluminum bars instead of winding, that is ribbon type of conductor. These are referred as rotor bars or aluminum bars. These rotor bars have been placed in rotor slots. You can observe in figure number 1 parallel sided rotor slot which houses the rotor conductor, that is rotor bars. This rotor circuit is completed by two short circuit end rings. You observe very clearly the rotor bars both ends have been brazed by end ring which provides complete of rotor circuit. These are also called as short circuit rings. These end rings have been made by conductor, that is of copper conductor material. You can observe in the figure. If the rotor conductors have been parallelly arranged, such type of arrangement poses motor certain problems. Motor may refuse to start. Magnetic locking between stator teeth and rotor teeth. Motor produces more magnetic hum, more noise may be produced, and it produces a pulsating torque. All these are problems. So, to overcome these problems, the rotor bars have been arranged in skewed position as shown in figure 2. The skewing angle depends upon 10 to 20 degree or 30 degree as per design. You can observe in this arrangement of rotor bars, the motor overcome the what problems we have stated in parallel arrangement of rotor conductors. Motor overcome these problems. It starts very easily, the noise is less, it produces good torque, all are advantages. Hence, the rotor conductors are arranged in skewed position what we have discussed, all the problems have been mentioned here. Please you go through. The rotor conductors are not insulated from the rotor core because rotor current will flow through the least resistance path. The arrangement of rotor conductors and with slip rings, it looks like a squirrel cage. Hence, this whole arrangement looks like a squirrel cage. Hence, the name is called squirrel cage type rotor. Such a motor which utilizes this type of rotor is referred as squirrel cage induction motor. The rotor conductors are arranged in parallel as shown in figure 1. In this arrangement, motor refuses to start, motor produces more noise, motor is not produces uniform torque. Hence, to overcome these difficulties, the rotor arrangement is arranged in skewed position. The skewing angle depends upon design performance. Next one, slipring type of rotor. Sir, it is also referred as face wound type of rotor. You can see there some constructional points or circuit diagram of representation as shown in figure. In this type of rotor, point number 1, both stator winding and rotor windings are star connected. Point number 2, the stator winding is supplied by 3-phase AC supply. Point number 3, the star connected rotor windings are given to the one end of slip rings. Point number 4, the other end of slip rings are connected to external 3-phase star connected resistance. It is also referred as starter. These slip rings have been kept on the brush. It is not brush, it is on shaft. It may be kept on shaft position. Now you can observe the resistance position may be kept in minimum position and maximum position. Very important point is that this type of rotor winding has lower values of resistance. Hence, we can't start this type of motor without external resistance value. Otherwise, motor will affect from the least resistance value. It may affect from burning effect also. Hence, we can't start the motor. Hence, we have to keep initially resistance position is in maximum because we are adding this external resistance into the rotor circuit via slip rings. Getting the idea? All of you. Hence, before start at initial condition, we have to keep external 3-phase star connected resistance position in maximum. After keeping, we have to give 3-phase AC supply to stator winding. Motor will start very smoothly. It runs with some speed less than rated speed. If the motor is rated for 1500 rpm, motor may start at 1000 rpm. After the starting of motor, we have to go on decreasing the value of resistance. The corresponding speed of the motor increases. Hence, if you brings this resistance to minimum position or zero position, at this condition motor attains its rated value. Hence, motor reaches its rated speed. Hence, this external resistance circuit is also used to control the speed. Maximum, medium, minimum positions. Different speeds are possible. Once the motor runs at its rated speed, 3 slip rings have been shorted by pushing some metal collar arrangement on the shaft. Hence the motor runs. At its rated speed. Before starting of every time, we have to take this starting arrangement. Same points, these are noted here. Once again, the stator and rotor windings are star connected. The stator winding is connected to 3-phase AC supply. The star connected rotor windings are connected to slip rings. One end, the other ends of the slip rings are connected to a star connected external rheostat. The external rheostat is added into the rotor circuit because this type of rotor possesses very lower resistance. Hence, we can't start the motor with low resistance. Therefore, we can add external circuit in the rotor circuit. Hence, external rheostat is kept in maximum position. Once the motor is started, we can increase the speed by decreasing rheostat value. When the rheostat becomes minimum or 0 position, the motor reaches its rated value. Once the motor runs at its rated speed, hence 3 slip rings are shorted by pushing arrangement of metal collar on the shaft. Hence, the motor runs at its rated speed, and some brushes arrangement are lifted from slip rings to reduce the frictional losses. Hence, this external resistance is used for starting purpose as well as to control the speed of motor. Another big important derivation is there, rotor induced EMF frequency. For this, we have to consider certain things. Consider a 3-phase induction motor with running at n RPM. P be the number of poles, F be the supply frequency in Hertz. So, we are giving the supply from input side stator. As usual, P is the number of poles, that is stator poles. F be the supply frequency, or it may be stator frequency, it is in Hertz. When 3-phase AC supply is given to the 3-phase stator windings, a resultant magnetic field of constant magnitude is developed and which rotates at synchronous speed over the rotor conductors. The synchronous speed is given by Ns equal to 120 F by P. You call the equation number 1. At this condition, the motor is not started, yet it is in rest condition, that is n equal to 0. Hence, the relative velocity between rotating magnetic speed Ns and actual speed of motor, that is Ns minus n, becomes maximum because n is 0. Hence, maximum slip is developed, that is 100% slip is developed, or in the fractional value 1, S equal to 1. At this condition, both frequencies are same, that is rotor induced EMF frequency and applied frequency, that is stator frequency, same. That means, if I am assuming F dash be the rotor induced EMF frequency, F be the supply frequency, that is F dash equal to F. So, this condition of the motor performance is referred as transformer analogy. In the transformer, both primary side frequency and secondary side frequency both are same, but it is a static device. Up to this part of induction motor analysis is similar to transformer. Once the motor starts, the speed of the motor increases, that is, speed of the motor n increases. Hence, relative velocity between ns and n goes on decreasing, because n is increasing, the difference between ns minus n decreasing, then which is proportional to slip, the corresponding slip also goes on decreasing. And at the same instant, f dash, rotor induced EMF frequency also reduces, sir. Now, there is no relation between transformer and induction motor. The induction motor performance changes. Now, it is a rotating machine. And one thing we have to assume, rotor winding also consists number of poles. We have to assume same number of stator poles. Hence, rotor poles equal to P. This slip speed ns minus n is given by 120 f dash by P, where f dash is rotor induced EMF frequency, P is number of rotor poles. You call equation 2, sir. Hence, dividing the equation 2 by equation 1. Dividing the equation 2 by equation 1, you write ns minus n divided by ns equal to 120 f dash by P divided by 120 f by P. Hence, here you make ns minus n, both terms are printed as ns. It is not like that. Ns minus n divided by ns. This term is referred as slip. Slip equal to f dash by f. So, therefore, f dash equal to s times of f. Hence, rotor induced EMF frequency is directly proportional to slip and supply frequency. This slip value depends upon load condition. Sir, as load on motor increases, slip decreases. As the slip decreases, f dash also decreases. Try to understand the concept. F dash means rotor induced EMF frequency. S means fractional value of slip. F means supply frequency. Try to understand. Already we have solved the problem. Thank you to one and all.